a student came to me and asked me this question, which is just a question from the calculus textbook by James Stewart, and I didn't know what to do. The question is, if x is equal to ln of secant theta plus tangent theta, then we are going to show that secant theta is equal to cosh. This is the hyperbolic version of the cosine, cosh of x. So at first, this is what I did. It's just about solving equations, right? So x equals ln of secant theta plus tangent theta. Okay, I want to get rid of the ln. And by the way, this right here should remind you of what? The integral of secant theta. Yeah, it's a pretty nice result. But I don't want to differentiate both sides, so that is not going to be helpful. In fact, this question has nothing to do with calculus. It's just like identity practice. Anyways, I will just exponentiate both sides, so we can get e to the x is equal to secant theta plus tangent theta. Okay? Then subtract this from both sides, then we get secant theta equals e to the x minus tangent theta. And now what? Of course, this has nothing to do with that, right? It does not look like it, but they are supposed to be equals, So I look at this again, and I was trying to do some identity business. So secant is the same as 1 over cosine, and tangent is the same as sine over cosine. And then combine them, of course, that's 1 plus sine theta over cosine theta. And I just multiply the top and bottom by 1 minus sine theta. Why? I don't know. I thought it would work, but I didn't. The top is going to be 1 minus sine squared, which is cosine squared. And the bottom we have cosine theta and 1 minus sine theta. Cancel one of them. And we end up with cosine theta over 1 minus sine theta. Pretty nice, but it didn't help. Yeah, so I was like looking at this. For some reason, my brain was not working. Maybe I was just too tired that day. And yeah, so I had to, think about it. And this is how you do it. It's actually not bad at all. Okay, so it was hard for me because I was trying to go from secant theta to cosh of x. The truth is, this is so much easier if you go from cosh x to secant theta. Let me show you. Firstly, cosh x, you can write this in the exponential form, which is e to the x plus e to the negative x over 2. That's the key. Why? Because we know what x is already. You can just plug in and then work it out. Yes. Let me just finish this right here for you guys real quick. So when you have e to the x, which is ln of secant theta plus tangent theta, and then plus this is e to the negative of x, which is ln of secant theta plus tangent theta right here, and all over 2. It's nice because e and ln cancel. However, do not cancel the e and ln x yet, because this right here is a negative 1. You have to put this to a power here. So it's this thing to the negative first power, and then you can cancel out the e and also the ln. So the first part right here is just going to be secant theta plus tangent theta. However, once we put the negative 1 right here for the power, we get what? That's 1 over secant theta plus tangent theta. And to simplify this, you have a few ways to do it. You can write this as 1 over cosine and write this as sine over cosine, and you go from there. Another way to do it is just you multiply the top and bottom by secant theta minus tangent theta. And you will get just secant theta, tangent theta minus tangent theta on the top. And the bottom is secant square theta minus tangent square theta. And the truth is, this right here is just equal to 1. So nice. Yeah, because tangent square plus 1 is equal to secant square. So yeah, you can just work it out and all that. So this part becomes secant theta minus tangent theta. Pretty cool, huh? And then all over the denominator too. And of course, this and that gone, and then we just have 2 secant theta over 2. Cancel, cancel, final answer, secant theta. Yeah, I think this works. Truth be told though, if you want me to go from secant theta to cosh x, if you want to go backwards like this, yeah, I wouldn't be able to do it. Yeah, I think this works.